Right, if you're moving on to this higher tier conditional probability work, I need to assume that you're already comfortable with how to create and use a probability tree diagram. And if you haven't practiced that yet, there's no point moving on to these. So if you're not already comfortable with how a probability tree diagram works, go back to Jones the Sums and find the topics on probability tree diagrams in either the higher or the intermediate tier before coming back to this. Okay, with that in mind, let's take a look at how these differ. So we have a packet of wine grams containing 11 sweets. There are 2 green, 3 black, and 6 yellow. So that information would be exactly the same with the more straightforward probability tree question. The difference this time is that 2 sweets are selected, and the fact that the second one will depend on what the first one was will change the probability. With the other probability tree questions, 1 sweet would have been selected and then replaced. So the probabilities for the second one would be exactly the same as for the first. So let's see how this shapes up as a diagram. So the first event will be the first sweet being selected, and there are 3 possible outcomes for that: green, black or yellow. So the first sweet, green, black, yellow. The chances of it being green are 2 out of 11. Chances of it being black will be 3 out of 11, and 6 out of 11 for the probability of it being yellow. So that would be the first sweet. And then for the second sweet, again, there are 3 possible outcomes for each of what's happened with the first sweet. So we'll have a GB yellow, for that one, a GB yellow coming off the black sweet, and a GB yellow coming off the yellow sweet. Now, because 1 sweet has already been removed from the bag, the probabilities for each of these outcomes is going to be out of 10, because there's 1 fewer sweet in the bag. And if we work from here, if the first one was green, then the chances of the second one being green are now going to be 1 out of 10, because 1 of the green sweets have already been taken. For these, there's still 3 black in the bag because the first one was green, so that will be 3 out of 10. And similarly for yellow, there's still 6 yellow in the bag, because if we're coming up here, it's a green that's been eaten, and only 10 sweets left. So for each of these, they're all going to be out of 10. If I'm in this group, the first sweet was black, so the chances of the second one being black would be 2 out of 10. 2 because there's 1 fewer black in the bag, 10 because there's 1 fewer sweet in the bag. But for green, it will be 2 out of 10, and for yellow, 6 out of 10. And the sum total of all these possible outcomes has to be 1. So we've got 6, 8, 10 out of 10, 6, 9, 10 out of 10, 6, 5, 11 out of 11. So the branches should always add up to 1. For the final one, if the first one was yellow, chances of the second one being yellow would be 5 on top and 10 on the bottom, 3 out of 10 and 2 out of 10. So that's the first thing that we have to do, is to get all the probabilities clear on the diagram. So the probability that the 2 sweets selected are yellow, so probability yellow and yellow, means that I'm moving down my tree in the same direction always, so yellow and yellow. When you find yourself using the word and in probability, you multiply the probabilities together. So the first one yellow, 6 out of 11, and times 5 out of 10 will give us 5 6s, 30 out of 110. And you can cancel that down, but often it's easier to leave it as it is. And then for part B, calculate the probability that no black sweet is selected. Well, no black sweet would mean green and green, or green and yellow, or yellow and green, or yellow and yellow. So you could do it that way, or you could turn it on its head, because for no black sweet to be selected, that basically takes in every other combination other than containing black. But probably for this one, it's easier to actually go the way that I'd originally explained. So probability no black will be probability green and green, or probability green and yellow, or can't be anything off this branch, so or yellow and green, or probability yellow and yellow. So that will work out to be green and green, 2 out of 11 times 1 out of 10, or 2 out of 11 times 6 out of 10, or 6 out of 11 times 2 out of 10, or 6 out of 11 times 5 out of 10. So 2 out of 110, 12 out of 110, 12 out of 110, 30 out of 110. So that gives us 24, 54, 56 out of 110. We could have looked at that in another way. If we consider the situation where the outcomes for the first suite would be black or not black, and not black is the B with a little line above it, and for the second suite, black, not black, black, not black, the chances of the first suite being black are 3 out of 11. So the chances of the first suite not being black would be 8 out of 11. If the first suite is black, the second suite will be 2 out of 10, which means not black will be 8 out of 10. With this one, the chances of the second one being black would be 3, because the first one wasn't black, out of 10, which means the second one will be 7 out of 10. So the probability that no black suite is selected would be not black and not black, which would be 8 out of 11 times 7 out of 10, 7 8s of 56 out of 110, which is the same as we got by considering all the possible combinations. So there are different ways of approaching these. Okay, so if we now take a look at question 2. Bag contains 7 bananas, 6 cherry, 5 lemon and 2 pineapple sweets. 2 sweets are selected at random without replacement. Right, so let's set up actually that's quite a big one to deal with a tree, so let's see if we can deal with this without a tree. So 2 sweets are both banana. Well, the chances of the first one being banana will be 7 out of the total. And the total is 6, 12, 18, 20, so 7 out of 20. The second one being banana, well, there'll be 1 fewer in the bag because one's already been selected, and there will be 1 fewer sweet in the bag. So the chances of them both being banana will be 7 out of 20, 6 out of 19, 7 6s 42, 2 19s are 38, so out of 380. Part B. The 2 sweets are either both lemon or both pineapple. So both lemon, or means and, add, both pineapple. So both lemon will be 5 out of 20 times 4 out of 19, or both pineapple 2 out of 20 times 1 out of 19. So that's 20 out of 380 plus 2 out of 380, which is 22 out of 380. Part C. Exactly one of the sweets is pineapple. So if we now go back like we did earlier, the previous question, to, well, it doesn't matter what all the other sweets are, it's either a pineapple or it's not a pineapple. Chances of the first one being pineapple is 2 out of 20. So the chances of it not being pineapple is 18 out of 20. If the first one's pineapple, the second one being pineapple is 1, because one's already been selected, out of 19. So this will be 18 out of 19. And for this one, if the first one is not a pineapple, the second one not being a pineapple will be 1 less, because the first one was not a pineapple, out of 19, which makes that 2 out of 19. So for exactly one of the sweets to be pineapple means either pineapple not pineapple or not pineapple pineapple. So first one pineapple and second one not, or first one not and second one is. Those are the only 2 ways you'll get exactly one. Either the other alternatives are no pineapple or both pineapple. So we have 2 out of 20 times 18 out of 19, or we have 18 out of 20 times 2 out of 19. So that's 36 out of 380 plus 36 out of 380, which is 72 out of 380. And then for the last one, part D, at least one of the sweets is lemon. Well, for at least one of the sweets, that means it's every possible outcome other than no lemon, that neither of them are lemon. So a way to approach this, which means we don't have to consider all the possible outcomes, is we know the total probability is 1. So if we take off the total probability, the only occurrence which doesn't satisfy that, which is not lemon and not lemon, then that will work that out straight away. So the probability of it not being lemon, well, in the first one, sorry, it's just dropped off the screen, there are 5 out of 20 lemons. So the chances of the first one not being a lemon is 15 out of 20. And then for the second one, if the first one is not a lemon, that means there's one fewer not lemon in the selection. So for the second not lemon, it'll be 14 out of 19. So that is 15 lots of 14, 210 out of 380. Well, a whole is 380 out of 380. So that gives us 170 out of 380. So that's another way of dealing with these. If the question is suggesting at least one, then there's only one outcome that doesn't satisfy that, which is first one's not lemon and second one's not lemon. So if we take that off 1, that will give us all the others combined. Question 3. So a clown has 7 pairs of shoes, 1 pair in each of the colours of the rainbow. The shoes are kept in the trunk in a dark room. The clown selects 2 shoes at random. What's the probability that the clown selects 1 left shoe and 1 right shoe? Well, there's 2 ways that we're working with this information. One is to do with colour, but the first occurrence is left and right. And if he's got 7 pairs of shoes, that means he's got 14 shoes, 7 of which are left and 7 of which are right. So probability for the first shoe being left or right will be 7 out of 14 and 7 out of 14. And then for the second, left, right, left, right. If the first one's left, that means there are only 6 left shoes still in the cupboard out of 13, but there are still 7 right shoes out of 13. If we're down in this branch, the first one was right, so there'll only be 6 right shoes left out of 13 and 7 left. So what's the probability that the clown selects 1 left and 1 right? So that's going to be either left then right, or right then left. So we've got 7 out of 14 times 7 out of 13, or 7 out of 14 times 7 out of 13. Which gives us 49 out of 182 plus 49 out of 182, which is 98 out of 182. What is the probability of selecting a matching pair of shoes? Well, for a matching pair of shoes, now we're either going to be selecting probability green, hang on, what are we talking about? Colours of the rainbow. So red and red, or green, red, orange, and orange, red, orange, or Richard of York, yellow, yellow, green, green, blue, blue, 1, 2, 3, 4, 5, indigo, violet. And the probability of red and red, the probability that the first one is red will be 2 out of 14. And if that one has been selected, the probability of the second one, there'll be one fewer red in there, will be 1 out of 13. And that will be exactly the same for each of the other combinations. So we end up multiplying that by 7, because they'll all end up the same probability. So that will be 2 out of 182 times 7, which will be 14 out of 182. Question 4. A bag contains 5 red, 4 blue and 1 white. 2 balls are drawn at random without replacement from the bag. Calculate the probability that the 2 balls are the same colour. Okay. So, the chances of it being red and red, or the chances of it being blue and blue, or the chances of it being white and white. So red and red will be, there are 10 balls, 5 out of 10 times 4 out of 9. Chances of it being blue and blue will be 4 out of 10 times 3 out of 9. And the chances of it being white and white will be 1 out of 10 times 0. So there's a 0 probability of you getting 2 whites because there is only one in the bag. So that gives us 20 over 90 plus 12 over 90, which is 32 out of 90. For part B, probability that at least one ball is blue. So if we think blue, not blue, blue, not blue, blue, not blue, for the first ball, The chances of it being blue is 4 out of 10. So the chances of it not being blue is 6 out of 10. The first one's blue. The second one is one fewer blue there, so it'll be 3 out of 9, which means that is 6 out of 9. If the first one's not blue, then chances of the second one not being blue is one fewer out of 9, which means that the chances of it being blue are 4 out of 9. So for at least one ball being blue, there's the only combination there that doesn't include one ball would be not black, not black. So if we take that away from 1, so 1 minus the probability of not blue and not blue. So not blue, first one 6 out of 10, not blue, second one 5 out of 9. So 1 I can write as 90 over 90. So chances of that happening are 60 out of 90. Question 5. Rice is sold in large bags. The bag of rice mixture is 60% white and 40% black. Now this one, on the original written solutions on my website, I went wrong. I didn't do this correctly. If I've got 60% white to 40% black, I could break that ratio down to 6 out of 4, which is 3 out of 2. So for every 5 grains in the bag, there are 3 white to 2 black. I ended up on the original solutions taking 1 grain off 100%, which is wrong. So what I can do here to turn that now into a tree diagram is, for the first one that's selected at random, if it's white, chances are 3 out of 5, and for black 2 out of 5. And then for the second selection, if the first one's white, the chances of the second one being white would be 1 fewer grain for every 5 in there, so it would be 2 over 4. Again, 1 fewer grain in total for every 5 that are in there. And then this one would also be 2 out of 4. And if the first one is black, the second one being black would be 1 out of 4, and that would be 3 out of 4. So the chances of them both being black would be 2 out of 5 times 1 out of 4, 2 out of 20, 1 out of 10, 10%. So there's a 10% chance that they would both be black. And then for part B, at least 1 grain of black. Well, that's the same now as with the previous ones, where if we've got black, not black, which we don't need to do because that's the same as what we've got up there. So at least 1 black means 1 minus both white. I started doing that again, but of course there are only 2 outcomes, so not black is white. So probability at least one black would be 1 minus probability white and white. Anything other than white and white will give us at least 1 black. So that would be 3/5 times 2/4. Written 1 is 20/20, 14/20. So as I mentioned, that is different to the answers that I've given on the website, but the ones on the website are wrong. So finally, question 6. 100 raffle tickets are sold. Tickets are numbered from 1 to 100. The raffle tickets are placed in a drum for a draw. 2 raffle tickets are selected, 1 ticket at a time, and not replaced. So odd and even. So if we consider them as odd or even, the first one, well, there'll be 50 out of 100 that'll be odd, and 50 out of 100 that'll be even. But depending on what that first one was, the probability for the second one will be different. So if the first one was odd, the chances of the second one being odd would be 49 out of 99. There's still 50 even ones in there though, so that would be 50 out of 99. If the first one is even, the second one, there'll be 1 fewer in there, and that will be odd, still 50 in there, 50 out of 99. So probability that the first one is odd and the second one is even will be odd, even, or even, then odd. So odd, even, 50 out of 100 times 50 out of 99, or even and odd so we've got 2,500 over 9,900. So when we add those together, we get 5,000 out of 9,900. And the probability that at least one of the tickets drawn is odd. So we could do odd and odd, or odd even, or even odd. Or we can do 1 minus even even, because that's the only outcome where there are no odds. So probability at least 1 odd will be 1 total probability less even and even. So even and even will be 50 over 100 times 49 over 99. So 1 is 9,900 over 9,900 minus 2,450 over 9,900, 7,450 over 9,900. There you go. So hopefully that will help you understand that level of probability work. You're looking at A star work there.